All right, let's look at some vector basics. All right, so vector is basically an arrow, and it carries two pieces of information. And first is the magnitude. So the length of the arrow tells you how big the vector is, and also the direction it's pointing to. All right. So let's say you have a vector v whose components are x1, comma so not x1, v1, comma v2, comma v3. Right? So these are exactly the same thing as the coordinates of the head of the arrow, assuming that the tail is located at the origin. Right? So, but the vector doesn't have to start from the origin. It can actually start from anywhere. For example, you could have a vector from P1 to P2, right? So the way to find the vector would be, so let's say P1 has a coordinate x1, comma y1, comma z1, and P2 has coordinates x2, comma y2, comma z2. Right, if you want to find a vector, let's instead of calling v, maybe it's more appropriate to call it the vector p1, p2. So it goes from p1 to p2. Right? So all you have to do is components can be found by just subtracting the coordinates. So if you're going from p1 to p2, we're going to do x2 minus x1. So that's going to give you the x component. And then, of course, a y2 minus y1 gives it a y component. And then you have a z2 minus z1 is the z component, right? So this is the vector p1, p2, right? So it's very easy. If you have a coordinates of the head and the tail, all you have to do is basically head minus tail gives you the vector, right? And also the length of the vector can be found this way. If you have a vector v1, comma v2, comma v3, all you have to do is square all components, then add them up, then take the square root. Right? So this is the length of the vector. Right? So if you have a vector 1, comma negative 2, comma positive 3, then all you have to do is just follow it. So if you square, so put the big square root. Right? A 1 squared would be 1, so I'll put that. Negative 2 squared would be positive 4, put that. And 3 squared would be 9. So this is going to be square root of 14. Right? So we can easily find the length of the vector. All right, another thing, operation that's important is a scalar product. All right, so it's basically a multiplication between between vectors. All right, so here's how it's defined. So if you have a vector v and w, right, vector v has component v1, comma v2, comma v3, and the vector w has a component w1, w2, w3. All right, so the dot product, so this is called scalar product. I like the word dot product, so this is also called dot product. And we use dot as its notation. All right, all you have to do is multiply the first component together plus the second component together plus the third component together. All right, so let's do this concrete example. So if you want to compute v dot w, right? So here v is 1, comma 2, comma 3, w is 2, comma negative 1, comma 3. All right, so what you do is 1 times 2, so it's 2, plus 2 times negative 1, so it's negative 2, plus 3 times 3, 9, so that's going to be equal to 9. So dot product, or a scalar product between these two vectors, is 9. Right? So it's very easy to compute. Right, so we can use the scalar product to detect the perpendicular vectors. So let's say if you have a vector v and a vector w are perpendicular to each other, then easy way to check is compute the dot product between those two vectors. If you get a 0 out of that, then they are perpendicular. Right, so let's look at these vectors. Let's find a dot product between v and the w, right? So we're going to do 1 times 2 is 2, plus 0 times 3 is 0, plus negative 2 times 1 is negative 2, so the sum is going to be equal to 0. So this implies that vector v is perpendicular to vector w, right? So if you're trying to see two vectors are perpendicular, all you have to do is compute the dot product to see if you get a 0. If it's not 0, then they're not perpendicular, right? And since we did perpendicular, we should probably do parallel vectors. So two vectors are parallel if one is a constant multiple of the other one, right? So here's an example, right? Vector v is 1 comma negative 2 comma 3, and the negative 2 comma 4 comma negative 6. These are parallel to each other, right? So the reason is this, right? If you multiply, so if you multiply, let's see, take v, multiply by negative 2, say, right? So you multiply the vector 1 comma negative 2 comma 3, right? So when you multiply by a constant, you multiply every single component by the same number. So this is going to give you negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. And negative 2 times 3 is negative 6, right? As you can see that this is exactly the same thing as vector w, which means that the v and w are parallel to each other. Right? So this were some vector basics. Right? That's it. I hope that this was clear.